So hello guys and welcome back to day 4. Yesterday we built our first machine learning model and that is a very big achievement. But today we take the next step. Today the theme is from basic model to better intelligence. So let's start understanding very important. Yesterday we created an intelligence but we built a model and trained it, made predictions and then evaluated it. But today we are going to optimize the intelligence because the first model, it is never the best model. Models can have errors. They may fail on new data. They may not generate good or well values. And this is where the real engineering becomes. Engineering is improving our system, improvising the intelligence. Now moving on to the next biggest problem, that is the underfitting and the overfitting. Underfitting means the model is too simple. It does not learn the patterns very well. And overfitting means the model has become too much more complex. It memorizes the whole data, but it fails in the real life systems or real life scenarios. As we can see in the graphs that are being given, the underfitting line, this is the line and these are the options that we need to mark. Okay, so underfitting line is just giving us a line, and if we add any values for the prediction, it is not going to provide us a clear cut solution. In case of overfitting as well, it has memorized, it is jotting down all the points. All the points that are been present here, they have been jotted down. That means it is not going to be the best option to solve our solution as well. Instead, this is a good fit line. It is having all the data, it is going through all the points, not all the points, but most of the points, and it will give a real or at least predictable predictions. Okay, so this is where underfitting and overfitting comes in. So the main point is about balance, and good fit, that means the product or the intelligence that we have been generating is generalized over all the solutions. Now, how are we going to improve our model? So there are 4 layers in optimization of any intelligence. So first of all, we need to have a better data to build the foundation of our project. The second thing is about using better features, that is extracting the right signals, extracting the right values and then loading them. The third thing is using a better algorithm, upgrading the core logic to fit our logic into the project so that it gives us the best fit line. And the fourth level is about better tuning. That is about dialing in the parameters, changing the values to get an optimized level of solution. This is not just guessing game. This is about systematic process. Now let us move on to talk about features as well. Not all features are equally important. Like in the previous video, we discussed about how nitrogen was important, how much the moisture content in soil was important, how the temperature and humidity were important while we were discussing about the fertilizers, which fertilizer to use in which kind of soil. So in this case, we also observed what particular feature was important and what particular features were not that much important. So some features carry strong signals, the others just have some random noises. For example, moisture and nitrogen will be efficient to improve our fertility index. So better input will lead us to the better output. Now talking about decision tree. Now let's upgrade our system to look at it from the algorithm perspective. So decision tree works like, if the decision that we are giving is correct, that is a decision, it is very easy to understand. It handles all the complexities, but it can overfit if it is not controlled properly. So there comes the more powerful model, which is the random forest. Instead of one tree, we use many different kinds of trees. Each tree votes and the majority is then going to win. This makes it more accurate and more stable compared to decision tree. Less overfitting means better performance. This is widely used in the industry since it gives us the more better complexity score and it gives us better accuracies as well. Now let us talk about comparison. Logistic regression, decision tree and random forest. Accuracy improves little by little. Compared to logistic regression, which we saw in the last lecture, the interpretability was high, the speed was fast, but we had very little accuracy. Compared to that, decision tree will be having a very high interpretability. It will be super fast and it will also give accuracy, which will be better than logistic regression. But talking about random forest, since many trees are involved and each tree votes, the interpretability will be very low, but the speed will matter because there are different kinds of trees, each tree votes, and due to that accuracy will go high but speed will comparatively be lower. Now this is your wow moment. When you switch from simple model to ensemble model, you see big jump in performance as well. Now let us move on to talk about matrices as well. We use multiple matrices to calculate the scores. So first matrix that we use is about accuracy. Then we also need to look about precision, recall and the F1 score. Accuracy is overall correctness about the data. That is total right predictions divided by total number of predictions. Talking about precision, it is a quantity of predictions that are coming. Like how many quantities or how many points that we have mapped are like closely assigned with the real values. Then there is recall, which is catching all of the positives about all the actual true cases. How many did we find? How many were actual true? How many were actual false? How many were negative truths and negative falses? Then we also have F1 score, which means the balance, which is the harmonic mean of both precision and the recall. Now we will move on to like cross validation. So what exactly is about cross validation? Okay, so instead of using just one train and split data, we test multiple times. And since we are training multiple times, we will be getting a better amount of data to rely upon. So now let us look about hyperparameters. Now we'll move on to the final like level of improvement, which is the hyperparametering. In these settings we control like the depth of trees, the number of trees that we need to add. Then we also need to think about it like it is a machine, tuning a machine. So the today's task is going to be simple. We will take our model from yesterday and we will be trying to improve it. Try decision tree, try random forest, and then compare the results of all. And the last question that you have to ask yourself is which model works the best and why does it work the best? And tomorrow we will be moving on to making a clear cut dashboard. Your model will be becoming a real system tomorrow. And remember this, an engineer does not stop building things. He improves until it works better. Now, enough of theory. Let's actually improve our model. Open up your Google Colab. Today, we are going to upgrade your intelligence. And let us now move on to Google Colab. So hello guys and welcome back to our Google Colab, our library or our workforce where we are going to now make our AI better. So now today we are not just going to write code from scratch, we are going to improve our previous system. Yesterday we built a model to predict the fertilizer, but today we are going to do something smarter. We are going to change the problem and get better at learning it. So let's begin by importing all the libraries. So what kind of libraries did we import? So first of all it was pandas, then it was numpy, then it was sklearn. From sklearn we got train and split. Then we also had standard scaler and label encoder. We also had accuracy score to measure all the accuracies, then classification reports and all as such. We also had matplotlib and we also had Seaborn to draw the plottings and all. So instead of just writing all the code for that, I am going to just copy and paste it. Okay, copy and paste is not allowed. So import pandas as PD, then import numpy as np. Then we have from sklearn dot model underscore selection. Okay, we didn't have this runtime connected, so I am connecting it to the runtime. Selection import train underscore test underscore split. Okay, from sklearn dot pre Reprocessing. I'm going to import standard scalar, comma, label encoder. Label encoder. Then from now we are going to import few new libraries as well. So last lecture we imported logistic regression. In this lecture we are going to improve on two more models. First of all, which is decision tree classifier, and the second one is going to be random forest. So from Scikit-learn dot linear model, we are going to import logistic regression. Logistic regression from Scikit-learn dot trees, we are going to import decision tree. Okay. Decision tree classifier, and from Scikit-learn dot ensemble. Scikit-learn dot ensemble, I am going to import a random forest classifier. Okay. And next thing, for checking the accuracy scores also we need to import metrics. So from Scikit-learn dot metrics, Scikit-learn dot metrics, I am going to import accuracy score. Okay. Now I'm going to run it first of all. Okay, the process has been executed. Now I'm going to add my data set. So I'm going to search for my data set and it has been added. So it is being added and it is showing me the warning. I'm going to click on OK since I know what the warning is. It is asking me to store it somewhere safe. The data will be lost after the runtime disconnects. I am going to copy its path, and in the next code line, I am going to add the description of this data file or data frame where the model has to fetch the data from. So for them, I am going to define it, and for defining, I need df equals to pd underscore read csv. I'm going to need pd dot read underscore csv. Okay, read underscore csv, and in this I am going to add about control v. That is the data where we have stored. Now let's just trust the data for now. We already have explored it yesterday, and we will be now moving on with our biggest challenge. That is, yesterday we predicted the fertilizer, and today we are going to predict about crops. So let us define Y as crop type. Okay, yesterday we defined it as fertilizer type. Today we are going to, okay, let us run this df command to see what kind of things are there. So just like yesterday, there is humidity, temperature, moisture, soil type, crop type, nitrogen, potassium, phosphorus, and fertilizer name. There are total of 8,000 rows, which is very little compared to what the agricultural sector needs. And there are also very little number of the sets on which the classifier has to be trained. There are only 9 columns. So in the real life data sets or in real life scenarios, we need much more data to predict upon. जितना ज़्यादा data उतना अच्छा हमारा the more the data, the more accurate our results are going to be. Okay, so now in the next code I am going to type here as y equals to df, and in here I am going to write about crop type. Okay, I am going to write here about crop type. Why? Because crops demand strongly depends on the soil and its environment. So model can learn better patterns. So now we are also going to define the inputs. So let us define the inputs as well. That is going to be x equals to df dot drop. So first of all, we are going to drop few columns. So what type of columns do we need to drop? First of all, we do not need the fertilizer name, and the second thing is we do not need the crop name as well. Okay, so we are going to drop these columns, that is columns equals to, and here I am going to define first of all the crop type, and the next is going to be comma the fertilizer name. Okay, the most important is we remove the fertilizer name because it is text and it is not needed right now. Okay, so it is giving me some, it is asking for some error actually. So yes, it has been cleared. Okay, so this has been cleared and I am going to add the new line. Okay, the crop name and crop fertilizer has been cleared off. So now we are going to move on with encoding. So for encoding, I'll be needing the label of LE as we looked in the label encoder. So where LE is the label encoder. So LE equals to label encoder and open close brackets, and Y equals LE dot fit underscore transform, and in transform I am going to write about df. In df I am going to write it's about its crop type. Okay, crop type. Okay, so now it is going to predict our y, which is our crop type, and it is going to label it something. So now crop type is going to be numeric. So next we need to also convert soil type into columns. So how are we going to convert soil type into columns? So for that we need another code, that is x equals pd dot get dummies. So instead of assigning any numbers, we are going to create a separate column, which will be much better for learning purposes as well. So get dummies, and in dummies we are going to write about x comma columns, which is equal to soil type. So in this soil type, and control enter. So this code has also been executed. Okay, so now this is much better for learning purpose for the model. Now we are going to split the data set into training and testing. So how did we like split it in yesterday's code? We divided it over 0.8%, sorry, 0.8 part for the testing part, so training part, and 0.2, that is 20% for the testing part, and random state which we had set 242. And we also need to include one more variable which is about stratifying. So stratify means we have to define the value of y. So for that we are going to now encode it, split the data. Now we are going to split it in this way: x underscore train comma x underscore test comma y underscore train comma y underscore test equals train test split. Okay, so train test split, and in this I am going to write about x comma y comma test size. Okay, test size as 0.2, which is 20%, and random state. So random state I am going to define, it as 42, and stratify equals y. Okay, stratify equals y. Now I am going to run it so that it splits into two. Okay, so there has been some problem as well. So this should stratify, yes. On running, it has completely executed, so the data set has been split into 80% and 20%. So stratify is the thing that ensures equal distribution. Okay, now we are going up to scaling our particular model. Okay, so for that we need to include a scalar. Okay, scalar, and in this scalar function I am going to define scalar as, we need to use the library of standard scalar, and we are going to define it as x underscore train underscore scaled equals scalar dot fit underscore transform, and in this I am going to write about x underscore train. So scaling is the thing that we only need for logistic regression and not for other tools, which is decision tree and random forest. So I am going to write the same unit for testing as well. So x underscore, instead of train I am going to write test scaled. So scalar dot fit, scalar dot transform, and x underscore test. Okay, scalar dot transform x test. Okay, so now I am going to run this particular code. It has been executed. Now the next thing that we are going to look for is a logistic regression. So I am going to add a new subheading which is about logistic regression. So in logistic regression I am going to specify LR, which stands for logistic regression. It stands for logistic regression, LOG. Let me start it again. LR equals to logistic regression of maximum iterations, max underscore iter, which is equal to 2000. Okay, and in that I am going to get some fit, that is LR logistic regression dot fit, which will be x train and y train. So x underscore train underscore fit scaled, and the second one is going to be y underscore train. So it is going to train among these two variables, that is x train scaled and y train. Okay, and the same goes for prediction as well. So LR underscore pred equals to LR dot predict, and we are going to add it here, x underscore test underscore scaled. Okay, and for accuracy, LR underscore accuracy, it will be defined as accuracy underscore score, accuracy score of y test and LR predicted, y test y underscore test comma LR underscore predicted. Okay, now I am going to run it, and it has completely successfully run the particular program. And now we are going to move on with decision tree as well. So 0.09125, that is almost 9%, it is accurate. And the accuracy is not going to be too much since we don't have too much of data. So imagine like getting almost like 11% of accuracy is also considered to be good on current, like this particular data, 11 or 12, or let's say not the data set is not going to give us margin of more than 15%. So be prepared for that as well. Now by this we have completed our logistic regression, and we are going to move on with decision tree. So decision tree, and in decision tree we are going to write the code for that. For that I am going to define dt, which is equal to decision tree classifier DCISION, decision tree classifier, and in this I am going to put maximum depth of tree, maximum underscore depth of tree, which is equal to 8, and I am also going to write random state which is 42, as we have predefined it in the other code as well. Then dt.fit I am going to write here the same things again, which is x train and y train. So x underscore train comma y underscore train comma y underscore train. Okay, and after this I am going to write about prediction. So dt underscore pred will be equal to dt dot predict predict, and in this I am going to predict about x underscore test. Okay, and after this I am going to present the accuracy as well, dt underscore accuracy, which is equal to accuracy underscore score of y comma test. Okay, so accuracy score of y test and dt underscore pred. Okay, so I am going to present the prediction score as well, which is going to be dt underscore accuracy. Okay, and control enter. It is going to give us 11% of accuracy. So decision tree is giving us 11% of accuracy. Now we will move on with the random forest. So instead of, let us check, instead of 8, what would have happened if we have put here 4? Control enter. So it would have given me accuracy of 0.98125. Okay, so the accuracy level has gone a pretty little much down as well. So now we are going to move on with random forest, which is the most powerful one. Okay, and in this we will be trying to get a better accuracy. Okay, so we will move on with the code. First of all, I'll have to add a text here about random forest, and okay, here we need to add a subheading, right? So we are going on with code right now, and I'll have to define, that is random forest equals to random forest classifier, and in this classifier I'll have to give the estimator and underscore estimator, and estimator, that is 200. Then we also need the maximum underscore depth, which will be 12, and random state which is going to be 42, right? And after this I'll be writing the same thing, that is here we wrote x train y train for fit check, and we are going to also write it here. So instead of rf I need to confirm if here there is dt, and I'll have to remake it to rf.fit on x train and y train. Then again I have to do the same things that we did here. Instead of dt, that is decision tree, I'll have to write about rf. Here as well we need to write about rf, random forest accuracy. Here we need to predict, so random forest predictions, and here we also need random forest predictions. And instead of dt accuracy we need rf accuracy. Control enter. It is going to run. It is going to take some more time compared to decision tree, and it has given us the prediction which is almost 0.1, that is 10%, correct? So if I improve this maximum depth, I don't know this, I don't want this code, I don't know what would happen if I write here instead of 12, if I write here 18. Let's check what would happen if I write maximum depth as 18. It is going to run, and it is giving us the lesser amount of accuracy. So we'll have to retune it. So this process is called retuning, changing the parameter so that we get a better result. Okay, now instead of 12 I have made it 14, it is giving us 0.08%. I'll write 10 here. So I'm going a little bit lower than maximum depth, which was 14. So again, it is going to give me 0.9. So better one is to keep it 12. Let us check what result does it give us. So it is giving us 0.1. So the maximum limit that it can reach is 0.1, which is the better accuracy compared to all of them. So now let's compare everything. Let's compare all these models in one go. So let us write here about results, and in the next line of code I am going to write about model comparison. So print, and in this model comparison. Okay, this should have been in closed brackets. Okay, model comparison, and here print. First of all, we are going to print about logistic regression. So logistic regression, and in this I am going to print about LR underscore accuracy. Okay, then the same goes for all three. So enter paste and enter paste. So the second one was decision tree, DECISSION TREE, and the last one was, but obvious, random forest, right? So instead of LR underscore accuracy, I'll be writing DT accuracy, and here I'm going to write RF accuracy, right? So control enter, and it is going to print me. Okay, this should have been inside, and here there should have been comma, right? So these are few basic mistakes that even you need to avoid. Okay, control enter, and it is going to give us the model prediction score. So logistic regression gave us almost 9% accuracy. The decision tree gave us 9.8% accuracy, and the random forest gave us 10% accuracy. So see this particular thing. Random forest is performing best on this particular data set. So that is why we need to compare different models. So there are different models. There are gradient boosting models. There is XGBoost model. So try to learn about these models, different models, and check which performs better, the random forest model, the decision tree, XGBoost, or gradient boost. So this is what the thing that matters the most. Okay, these are the most important factors. Now we are not just predicting, we are understanding the system. So let's test this particular data in real life. So first of all, let us look at what data frames or what particular features are the most important features that the machine has predicted to work upon. Okay, so for this we need to check important features. Importance equals pd dot data frame, and in this data frame I am going to write about, first of all, feature which will be presented in x dot columns, and another one that is importance which will be presented in rf dot feature importances underscore, and then we'll have to write about dot sort underscore values. So it will be sorting all the values upon the importance values. In bracket I'll have to write by equals to, so first of all I'll have to sort them in terms of importance and in ascending order. So randomly ascending equals false. Okay, so we'll be predicting the important feature. So print, and in print I'll be writing about important features which are comma, importance dot head, and in brackets I'll be writing 10. Okay, jitne bhi honge. So yes, control enter, and it is going to provide us with all these features. So instead of false, if I have written here true, control enter, okay, nothing changes, it seems. So these are few important features based on which the thing has been classified. So what feature is important or what feature is not important. So the most important feature that we can see here is this, which is almost 18.5%. Then this is the next one, temperature, which is 18.1%, moisture is 17.9%, nitrogen is 13.8%. So these are different features which are important in our model. Okay, now we are going to check it on any random kind of thing. Okay, random data. Okay, so just like yesterday what we did, okay, let this be for your homework, so that even you guys would like to predict these things. So in yesterday's case, as we saw it here, we solved everything. Okay, so this was about feature importance, and these were the real predictions that we performed. So just like this, take all the predictions and try to predict what crop would grow in which condition. So this is going to be your final system, and let's summarize what we actually did today. Okay, so first of all, starting from start, we first of all imported all the libraries that we needed, which were pandas, numpy, and from Scikit-learn, we imported few libraries such as first of all training and testing splits. Then we also imported standard scalar and level encoder. Then we had three different models, which were logistic regression, decision tree classifier, and the random forest classifier. And the last was about metrics, which was for checking the accuracy score. First of all, we imported the data, we loaded the data in our model. Then we set why or the what we need to be predicted. So for that we took it for the crop type. Then we moved on for the next thing. We removed the crop type column and the fertilizer column from X, which was going into the training part of the data set. Then we labeled the crop type so that we need to transform it. Then we split the data into 80% and 20% phases. Then we applied the standard scalar for logistic regression. We performed logistic regression on the model, by which we got accuracy of 91%. Sorry, 9.1%. Then we moved on for a decision tree, at which we got the precision of accuracy of 9.8%. Then we also tried it upon random forest, by which we got accuracy of 10%. And these were the results that we performed and the important features that we got. So yeah guys, that's it for today. This is a real machine learning, and tomorrow we will convert this all into real application, a dashboard where anyone can use your model. So because now we are not just coding, we are building a real life system, a real working system. And that's it for today guys. See you all in the next video. See you all tomorrow.